We're talking about Atlas again. We have some updates and some new discoveries. And in case you don't know what I'm talking about, this is of course the third interstellar object or interstellar comet discovered in July 2025 that scientists have been rushing to study over the past few months. And now the comet has just completed the most intense part of its journey, where it passes through perihelion, or the closest point to the Sun. But unfortunately for us, during this crucial period, is completely obscured by the Sun, and can only be seen from planets like Mars. We actually discussed observations from Mars in one of the previous videos in the description, but I mean, in case you're curious, there's not much to see. But despite this, a lot of space-based instruments have been focused entirely on this comet, just because it's a rare event. But now that it's reappeared from behind the Sun, researchers have a new opportunity to observe it again. And we've had some first discoveries, but today we're not really reiterating some of the old facts, which, as usual, you can see in some of the previous videos in the description. And we're not discussing any of the basic facts, for example, speed, size, age. All of this has been covered before. Instead, we're just going to focus on some of the most recent updates, and specifically the ones that might be a little surprising, and the ones that reveal the true nature of this object. But a lot of these discoveries are obviously extremely exciting, simply because the age of this comet is thought to be 7 billion years old, or even older. It's really a time capsule. It's not releasing material that's billions of years old, giving us unprecedented insight into the ancient history of the galaxy. So what exactly happened during perihelion, the moment the comet was closest to the Sun? The answer came on October 29th, just a few days ago. At that point, the comet was only about 220 million kilometers from the Sun, which is roughly the same distance as the Earth and the Sun, only a little further. However, the comet was completely obscured from Earth, forcing astronomers to rely on space eyes like the SOHO and GO-19 observatories. These instruments, which are specially designed to block out the bright light from the Sun, allow scientists to study the solar atmosphere, and this time, they became the only witnesses to record the comet's dangerous journey. What they discovered was truly intriguing. Did the comet survive this violent encounter, or was it completely burned up by the Sun's giant plasma storm? Some researchers even hypothesized that its disappearance or change in orbit could reveal something unusual in the solar magnetic field, a mystery that scientists are urgently trying to solve. And the first discovery that really blew the scientific world away was this. Just before perihelion, between October 20 and 25, Comet Atlas experienced an unprecedented and rapid brightening. In a short time, it became brighter than ever before, so bright that if it could be observed from Mars, the view would have been breathtaking beyond imagination. However, what was remarkable was that this increase in brightness was so steep, unlike most other comets, which only gradually brighten as their surface ices evaporate into gas. Analysis showed that the brightness increased inversely to the power of 7, an extraordinary number, suggesting that something truly unusual was happening on the comet's surface. Researchers officially documented this phenomenon in a recent report, but because it was such a new discovery, no one knew what was causing it. One thing is certain: the comet's emissions increase dramatically as it gets closer to the Sun. But what has scientists even more baffled is the strange change in color that appears to make the comet bluer than the Sun. This is a significant turning point, because this drastic change indicates the presence of volatile molecules such as cyanide or ammonia, which emit strong light in the visible region. It is the blue light from these gases that overwhelms the red light reflected from the dust, creating the unusually bright color. Remarkably, this is the third color change that Atlas Comet has had. Previously, it had a mysterious green hue for several weeks, and the reason behind that color remains a mystery. This shows that the comet is in a state of extreme activity, emitting material many times more than normal comets in the solar system. These facts reinforce the hypothesis that Atlas could be an ancient object, formed on the far edge of an ancient star system and wandered in darkness for billions of years before first encountering sunlight A striking image from the Very Large Telescope has surprised observers even more. It recorded the dust and gas cloud around the comet, constantly changing shape, even creating an unusual hazy coating directed directly towards the sun, as if the giant star itself was stretching, bending and kneading the ancient traveler's gaseous envelope. Is this just a normal physical phenomenon, or is it a sign of an unknown interaction between the comet and the sun's magnetic field? That question is now urging scientists around the world to search for an answer. Not only that, the latest observations from the James Webb Telescope have opened up a completely different perspective on this mysterious comet. When viewed in infrared, the data confirmed once again that the comet's surface had been subjected to tremendous levels of radiation during its lonely journey through interstellar space, billions of years in the making. During that terrible time, high-energy cosmic rays from the galaxy bombarded the surface, layer by layer, dust grain by dust grain, ice molecule by ice molecule, transforming its original structure through a slow but persistent chain of chemical reactions. The result of this prolonged exposure was the formation of a dense, aged, and extremely impenetrable crust, estimated to be 15 to 20 meters deep, equivalent to 50 to 65 feet. This crust is considered an ancient geological record of the universe, recording every collision, every energy ray, and possibly even the chemical traces of the early solar system. If humans were to one day set foot on the surface of this comet, especially while it is still far from the sun, we would not be standing on a lifeless block of ice, but on a living witness to the early universe, an object whose crust has been forged over billions of years in the storms of space. Researchers say this could be the key to understanding how primordial matter in space evolved over time, and even open up the more daring question: could organic compounds once baked by cosmic rays contribute to the formation of life elsewhere in the universe? Once again, this comet is more than just an icy object floating in space. It could be a living memory of the universe, telling the story of billions of years of history that sunlight has only just touched. That billion-year irradiation also helped solve one of the first and most puzzling chemical mysteries scientists discovered in the Atlas comet: its incredibly unusual abundance of carbon dioxide CO2. In early charts, the CO2 levels recorded far exceeded any predicted model, leaving early researchers at a loss to explain its origin. But now, with new insights from infrared data, they believe the cause lies in the billion-year cosmic irradiation itself. During its wanderings through the galaxy, the comet was constantly bombarded by high-energy cosmic rays, causing the carbon monoxide on its surface to slowly oxidize into carbon dioxide. As a result, over billions of years, the entire outer layer of the comet had accumulated a huge amount of CO2, enough to produce the unusual enrichment signature observed by the James Webb Telescope. For astronomers, this is a paradigm shift. The discovery suggests that the gas and ice that escape from comets is not the primordial material of the universe, as previously believed, but is actually processed matter, chemically altered over billions of years of interaction with cosmic radiation. In other words, what we are observing is not the pristine material that formed the first star system, but a restructured version after billions of years of enduring the harsh environment of interstellar space. This raises an intriguing question. Could there still be layers of primordial ice hidden deep beneath that old crust, unaltered material, that could tell the story of the comet's true origins? With luck, the intense heat at perihelion could erode the outer crust, revealing pristine layers of ice that have not been exposed to light for billions of years. And when that happens, we might be able to see for the first time the chemical traces of that early age in some distant star system where Atlas might have been born. More intriguingly, the Atlas comet also revealed another unusual chemical composition, a slightly higher nickel content than other comets in the solar system. While not conclusive, this finding suggests that other star systems in the universe may be made up of different proportions of heavy elements, opening up a whole new field of study into the diversity of planetary matter in distant galaxies. In this way, Atlas is more than just a comet approaching the Sun. It is also a time capsule, preserving the complex chemical story of the universe, and each new observation of it could reveal another chapter in the evolutionary history of cosmic matter. A follow-up study has opened up a whole new and fascinating perspective on the role of interstellar comets. The central question is, why is it important to study these interstellar travelers? The answer, scientists say, could fundamentally challenge what we once believed about how planets form. In the standard model of planet formation, cosmic dust and small particles collide, gradually clumping together to form larger and larger objects, until a fully formed planet forms. However, this model faces a classic obstacle known as the meter barrier. Once objects reach a size of about 1 meter, instead of sticking together, they start to bounce and shatter upon impact. A paradox that has puzzled scientists for decades. If rocks can't keep sticking together, how did the first planets form? It's here that the new research proposes a bold hypothesis. Interstellar comets could be the answer. These ancient objects, which wandered the galaxy after being expelled from their parent star systems, may have been accidentally captured by the gravitational forces of the dust disks surrounding young stars. Once trapped in these disks, they became the primary nuclei, or cosmic seeds for other dust particles, to cling to and accumulate rapidly, creating the conditions for the birth of new planets. This, if true, could radically change the way we think about the evolution of planetary systems. This capture and seeding mechanism could also significantly shorten the time it takes for planets to form, especially in high-mass systems. In fact, stars more massive than the Sun seem to be more efficient at attracting interstellar objects, which may be why giant planets like Jupiter are more commonly found around such stars. Of course, this is still just a bold hypothesis, with no direct observational evidence or real-world simulations to confirm it. But if it is proven, it would offer a stunning prospect that even our own Earth may have been formed by an interstellar comet that wandered too close to the Sun 5 billion years ago, accidentally becoming the seed for life and human civilization. It's a possibility that sounds like science fiction, but if true, it could reveal that all worlds in the universe, including our own, share a common origin from ancient interstellar dust particles, seeding life everywhere light has yet to reach. When it comes to the next phase of technical observations, things are really starting right now, as Comet Atlas exits the Sun, marking Chapter 2 of humanity's observation journey. The first post-perihelion observation took place on Halloween, when the Lowell Observatory LA Discovery Telescope captured the latest images. The good news is that the comet is still intact, looking like a real comet, and not some alien spacecraft, as many humorously speculated. And the good news is that the comet can now be seen with amateur telescopes, especially in the northern hemisphere, although it is still quite faint. At dusk in the morning, if the weather conditions are favorable, observers can see it as a long, faint streak of light moving north. In the coming weeks, its brightness is expected to increase slightly, promising to bring more detailed images and footage to the astronomical community around the world. Currently, a series of space and ground telescopes are simultaneously pointing their lenses towards Atlas. Among them are veterans such as SOHO, Punch, Hubble and James Webb, along with the interplanetary missions Lucy and Psyche, which happen to orbit the region of space where Atlas is traveling. This opens up a precious opportunity to collect chemical and spectral data of the comet over the next few months, a rare opportunity that scientists cannot miss. The most important highlight of this journey will come on December 19, when Comet Atlas makes its closest approach to Earth. At this point, observatories around the world are expected to collect a series of close-up images, videos, and detailed spectroscopic data. revealing more about the comet's internal structure and workings. In particular, the Clipper mission is expected to fly through Atlas' plasma tail, collecting dust and ion samples to send back to Earth, a major step forward in understanding how comets interact with the solar wind. Then, in March 2026, Comet Atlas will approach Jupiter, but at a distance and orbit that will make observations nearly impossible. Moving so fast, Atlas will leave the neighborhood of the solar system and never return. That means we have just a few short months left to collect every possible data, every photon of light, every plasma dust grain, every faint spectrum. Because once Atlas disappears into the darkness of deep space, the mysteries it carries may have to wait centuries to be revealed again. Based on all the observations that have been collected, it can once again be affirmed that Comet Atlas is an extremely strange and unpredictable object. The fact that it changed color up to 3 times and glowed unusually brightly when approaching the Sun was enough to confuse scientists, because no previous comet model had ever predicted a similar phenomenon. These signs show that complex physical and chemical processes are taking place inside Atlas that humanity has never recorded, and to understand more clearly, we will need a lot more observations and additional data in the near future. What is even more shocking is the discovery of a shell that has been irradiated to a depth of several meters, which forces scientists to reconsider the entire approach when analyzing comets. Obviously, that shell is no longer the original matter of the universe, but has been restructured over billions of years of exposure to cosmic radiation. That makes Atlas a living natural laboratory, where every speck of dust tells a story about the history of the formation and evolution of matter in interstellar space. With all that being said, Atlas deserves to be called one of the most extraordinary objects to visit the solar system in the past decade. However, studying it requires scientists to cultivate a kind of negative capacity, a comfort with the unknown. We must accept that we may never have all the answers because observation time is running out, and many questions may remain in the darkness of deep space. Nevertheless, Comet Atlas has been, is, and will continue to be an endless source of inspiration for astronomers. The coming weeks promise to bring more data, images, and perhaps even unprecedented surprises. And however Atlas's story ends, it remains a powerful reminder of the mystery and grandeur of the universe, where every ray of light, every tiny speck of dust, contains the secrets of billions of years of history. Based on all the observations that have been collected, it can once again be affirmed that Comet Atlas is an extremely strange and unpredictable object. The fact that it changed color up to 3 times and glowed unusually brightly when approaching the Sun was enough to confuse scientists because no previous comet model had ever predicted a similar phenomenon. These signs show that complex physical and chemical processes are taking place inside Atlas that humanity has never recorded, and to understand more clearly, we will need a lot more observations and additional data in the near future. What is even more shocking is the discovery of an irradiated crust several meters deep, which forces scientists to reconsider the entire approach when analyzing comets. Clearly, the crust is no longer the primordial matter of the universe, but has been restructured by billions of years of exposure to cosmic radiation. That makes Atlas a living natural laboratory, where every dust grain tells the story of the history of the formation and evolution of matter in interstellar space. With all that being said, Atlas deserves to be called one of the most extraordinary objects to visit the solar system in the past decade. However, studying it requires scientists to cultivate a kind of negative capacity, a comfort with the unknown. We must accept that we may never have all the answers because observation time is running out, and many questions may forever remain in the darkness of deep space. But before it disappears, some bold hypotheses are stirring the research community. Could the Atlas comet be an ancient messenger, hurled from a distant star system, carrying the chemical signature of a civilization that died billions of years ago? Or could its heavily irradiated shell itself harbor complex organic molecules, precursors to life, that we have yet to find in the solar system? Some experts have even questioned whether the intense cosmic radiation the comet has absorbed over billions of years could have created previously unknown organic synthesis reactions, turning it into a potential DNA repository drifting between the stars. If these theories are correct, Atlas could be the key to humans demonstrating for the first time the spread of organic matter between star systems, evidence for the panspermia hypothesis of the seeding of life throughout the universe. But to confirm that, we only have a few short months before Atlas is gone forever. But Comet Atlas has been, is, and will continue to be an endless source of inspiration for astronomers. The coming weeks promise to bring more data, images, and perhaps even unprecedented surprises. And however Atlas's story ends, it remains a powerful reminder of the mystery and grandeur of the universe, where every ray of light, every tiny speck of dust holds the secrets of billions of years of history, and perhaps even traces of life we're still searching for. If you want to follow this story as it unfolds, make sure you subscribe and turn on notifications for this channel. I'll be making follow-up videos as new data becomes available, especially after perihelion, when we'll see what happens to 3I Atlas after its close encounter with the Sun. Leave a comment below and let me know. What do you think we'll learn about this interstellar visitor? Will it survive perihelion intact, or are we about to witness a fragmentation event? I've read all the comments and am curious what you think.